Hi, I'm Matt Eland. I teach software engineering professionally, and I'm an Azure Data Scientist Associate. We all know that Python can do a lot with machine learning. But did you know that you can write Python code to take advantage of Microsoft Azure's cloud-based compute, storage, and automation capabilities? In this talk, I'm going to show you how the Azure ML Python SDK lets you register datasets, train models using automated machine learning, evaluate the performance of those models, register them for future use, and even deploy them as REST endpoints. You can do all this in around 100 lines of code. Let's take a look. Automated machine learning refers to the task of selecting a dataset and a high-level goal such as predicting car prices or determining if a mole is likely to be cancerous or not. Automated ML then automates the selection of a specific machine learning algorithm and hyperparameters for that algorithm by trying as many different algorithms that might work as it can in a window of time and then narrowing in on the best performing ones. This helps new data scientists significantly reduce the learning curve by allowing them to focus on the core tasks that they want to perform instead of memorizing all the available algorithms and the hyperparameters. It can also help more experienced data scientists find better performing algorithms that they might not have considered. Automated ML is available on the web in Azure Machine Learning Studio, but it can be faster and easier to share with others by running your experiments directly from Python code using the Azure ML Python SDK. Let's take a look at how a typical experiment works. Now, the first thing that we do is connect to an Azure Machine Learning workspace. We do this by downloading a config.json from the Azure portal, and then we put that in our local directory. From there, we can call workspace from config to connect to that workspace. After that, we're going to need to get either a pre-provisioned compute cluster that we set up in Machine Learning Studio, or we'll need to use code to create a new one. Now, this will allow us to use an Azure-based compute resource for our machine learning tasks and only pay for the time that we're actively using that cluster. After that, we take a CSV file and we load it into a pandas data frame. And we can take that data frame and register it in Azure as a tabular dataset. Now, if it didn't exist before, it's registered as a new dataset. But if it already existed under that name, then we actually automatically add a new version of that dataset in Azure so that we can track the way that our data has changed over time. After this comes the fun part. We need to configure our machine learning experiment and how it should behave. We select the task that we're trying to accomplish, that usually this is regression or classification. We give Azure a data set and tell it which column we want to predict and which machine learning metric is the most important to us when we're comparing two different models. We can then configure information on cross-validation, how many models to try, the compute resources to use, and how many different nodes in a compute cluster should be activated at any one given time. Once we have this configured, we create and we submit our experiment. This causes Azure to run our experiment and compare the various models that it generates until it finds the best performing model based on the validation criteria that we specified. The Azure ML Python SDK also includes some widgets that will actively show you the progress of a running machine learning experiment so you can monitor its progress directly in Jupyter Notebooks. Once a run completes, we can grab the best performing model and details on that run and get access to all the metrics and logs associated with it. From there, we can register this model in Azure so that it can be formally deployed. Alternatively, we can also download the files associated with the model for use outside of Azure. If we really like a model, we can deploy it as a REST endpoint directly from code as either an Azure container instance or as an Azure Kubernetes service with several different authentication and scaling options available to us. So that's the Azure Machine Learning Python SDK. I love this suite of capabilities and how accessible it makes data science, while still letting me keep control and direct things from code. If you'd like to learn more about Azure Machine Learning, check out my data science blog at accessibleai.dev and my YouTube channel at mattondatascience.com. Thank you for watching, and I wish you many successful machine learning experiments in your future.